Friends, today we are going to study the fourth chapter of NCERT Class 10 CBSE. The chapter name is Carbon and its Compounds. So shall we start? Before going to the chapter, let's have a quick look at the contents of this chapter. Okay, first of all we are going to discuss carbon and its properties. Here we will study about the basic characters of carbon, about its valency, the melting point, boiling point, and some new terms will be introduced to you in this topic. Then we will go through the covalent bonding, the type of bonding that the carbon will undergo to produce compound. Okay, and we will explain that with the help of a lot of examples and figures are used to represent these examples. Okay. Then after that, carbon compounds. So we are taking short steps. After studying about the type of bonds that the carbon is forming with the help of this covalent bonding, we will study more about large compounds which are formed with the help of these kind of bonds. Okay. After that, we will study nomenclature. Nomenclature doesn't vary just regarding this word, and it's just about the naming of these compounds. Okay. And for that there are certain rules, and we will go through all of that rules and practice each one of that with the help of examples. Okay. After that we will study the chemical properties of these carbon compounds. For that we will select a few compounds to study these chemical properties. We will discuss only some basic chemical properties of these carbon compounds. Okay. Okay, let's move to the first topic, that is carbon and its properties. So let's start with a very basic concept, that is the atomic number of carbon, which is 6 and the mass number is 12. Why I said is to give a short intro about the distribution of electrons in its shell. Okay, you may have already studied about the Bohr model of atom in your previous classes and the distribution of electrons in different shells. So, which was done with the help of this formula 2n square, where n represent the number of the shell. Here we have the K shell and the L shell. For K, n is equal to 1, and for L, n is equal to 2. So in the first shell, it can accommodate, with the help of this formula, we can calculate that in the first shell it have 2 electrons, and the second shell it will have 8 electrons. Okay. In case of this carbon atom, we have 6 electrons in total because its atomic number is 6, and the distribution is like this. They have 2 electrons in the first shell and the 4 electrons in the second shell. Okay. Now, come to this word, tetravalent. This indicates the number of electrons in its outermost shell. That is called tetravalent. Okay, that makes it carbon a tetravalent element. Okay. Then carbon forms what kind of bond? Covalent bond. You may have already studied about the ionic compounds in the previous chapters, where they form the bond by exchanging electrons. That is, they either form bonds by losing electrons or by gaining electrons. But in this case, we are forming bonds with the help of covalent bonds. Okay, we will study more about this kind of bonds and how they undergo this kind of bonding in the upcoming slide. Okay, they have low melting and boiling points. Why is it so? We will discuss that in the later portion of this class. Okay, then they are poor conductors of electricity, which also we will discuss. And the word catenation, keep in mind of these words, tetravalent and the covalent bond and catenation, the self-linking property, because we will come to these words multiple times across this chapter. Okay, shall we move to next slide? First of all, we have to understand why these atoms undergo a reaction. They are undergoing reaction to get an octet in its outermost shell. As I said, in case of carbon, that requires 4 more electrons to have an octet. Okay, they have a filled valence shell so that they can attain the nearest noble gas configuration. That is why these atoms are undergoing reactions. Okay. Keep in this mind this octet in its outermost shell. Okay, why they are undergoing? They want to have an octet in its outermost shell. Okay. Then about covalent bonding. For easiness, let's split this word covalent just for studying. Okay, covalent, we know the word cooperation, that is they are cooperating to have a happy ending. Okay, here also the covalent bonds are doing the same thing, that is they attain an octet in its outermost shell by sharing their electrons. They are sharing their electrons, they are not giving or losing, they are sharing their electrons. So the bonds which are formed by sharing of an electron between a pair of two atoms is referred to as covalent bonding. Okay, let's study that with the example of simplest example. Hydrogen atom, we know the molecule of hydrogen, how they formed. So hydrogen, they have a single bond between these two. How they are formed? We know that hydrogen with atomic number 1, they have a 1 electrons. Okay, they have 1 electron. And another hydrogen atom, they also have 1 electron. Okay, both of them require 2 electrons to have the nearest noble gas configuration. That is to have the configuration of helium. Okay, here by sharing, these hydrogen atoms get 2 electrons and here also these also get 2 electrons. Thereby they form a single bond. Do you understand? So let's study it with help of more examples. Okay, consider oxygen atom. What is its atomic number? It's 6. Okay. Then how will be its configuration? There are 2 electrons in the first shell and 4 electrons circuit. Study that with more examples. Let's consider oxygen atom or oxygen molecule, how it is formed. Okay, consider oxygen atom. What is its atomic number? It is 8. Then how will be its distribution? It has 2 electrons in the first shell, that is K shell, and the second shell, it has 6 electrons. So how many electrons would it need to have an octet? It will require 2 more electrons. Okay, it will require 2 more electrons. How they are undergoing? So oxygen atom, it will have 6 electrons. Sorry. Oxygen atom. Okay. They have 6 electrons in its valence shell. 1, 2, 3, 4, 5, 6. Okay. Another oxygen atom. This will also require 2 more electrons to fill their valence shell and to gain octet. Okay. What they will do? They will just share this electron. Okay. Understand? Here, 2 pairs of electrons are shared to form a bond and hence to gain an octet. So they will form a double bond. Okay, understand? In the same way, we are going to form how many, you are going to find how many bonds this nitrogen molecule will form. So nitrogen with atomic number 7. Okay, how will be the configuration? 2 and 5. It requires 3 more electrons to have an octet. Okay, then how many bonds will be formed? 3 pairs have to be shared. Okay, 3 pairs have to be shared and it will form a triple bond. Okay, then after considering this simple molecule, let's move to a simple compound also, that is water. Okay, in case of water, what it is there? There are 2 molecules, there are 2 atoms of hydrogen and 1 atom of oxygen. Okay. Okay, there are 1 atom of hydrogen, 2 molecules, 1 molecule of hydrogen and 2 atoms of hydrogen. Okay. And consider this. Hydrogen, oxygen, hydrogen. There are 2 hydrogen atoms and 1 oxygen atom. Okay. Oxygen, how many electrons are there in the valence shell? There are 6 electrons. How many more are required? 2 electrons. And hydrogen, there is 1 electron and both of them need 1 more electrons to have an octet or to have a stability. Okay. So, first of all, write the electrons of hydrogen and case of oxygen. There's 1, 2, 3, 4, 5, 6. Okay. Here, this kind of bonding. Here, they will share this. And in total, the oxygen will get 8 electrons. So they will form single bonds here. Okay, do you understand? Okay, let's move to the next slide. Covalent bonding. So now we know how they are formed. They are formed by sharing of electrons between the atoms. Okay, so why covalent bonding? We are going to study why covalent bonding. In case of carbon atom, they require 4 more electrons again octet. What happens? It gains 4 electrons, just like in ionic compounds. What happens if they gain 4 more electrons? They will become a C4 minus anion. But in case of C4 minus anion, the difficulty is the electron will be difficult to hold 10 electrons, because with increasing distance and number of electrons in the same shell, it will be difficult for the electrons to hold on to this the nucleus to hold on to these electrons. Okay, and by C4 plus cation, that is by losing 4 electrons from their valence shell, okay, it requires large amount of energy. A very huge amount of energy will be required for the removal of 4 electrons from its valence shell. That is why they can form a carbon 4 plus cation. Okay, we have already know this word catenation. They are the self-linking property of carbon. It's a unique property, but it doesn't mean only carbon exhibit that. Also silicon also exhibit, and some other elements also exhibit that kind of bonding. Okay, in case of carbon, what will they do? They can undergo self-linking. This property of carbon to undergo self-linking is referred to as catenation. Okay, keep this in mind. And here comes the reason for 2 properties that carbon exhibit, which we have discussed in the first slide. That is 2 properties: the melting point, the boiling point, and the conductivity. Okay, these carbon-carbon bonds formed by the covalent bonding is very strong. Okay, they are formed by sharing. Okay, they are formed by sharing and they are very strong. They are poor conductors of electricity, because instead of giving any ions or charged electrons, they are sharing electrons, and this will give them no charge ions to conduct electricity. That is why they are not conducting electricity. That is why that makes them poor conductors of electricity. Okay, then comes to the low melting and boiling point. Why is it so? It is because of the low intermolecular forces between these molecules. Intermolecular, that is a molecule of water, a molecule of another molecule of water. So it's just for example, this is not a carbon compound, but I am saying for an example, say 2 molecules of alcohol, which is a carbon compound. These molecules together, the bonds within them are very strong, but between them they don't have that much attraction or anything. So they have intermolecular forces weak. That is why they undergo melting and boiling at very low temperatures. Okay, then let's consider saturated and unsaturated carbon compounds. What make it different? Okay, we already studied about double bond, triple bond and single bond formed by covalent bonding. Okay, those compounds, those carbon compounds formed by single bonds are referred to as saturated compounds. But if they are formed by a double or triple bonds, then they are called unsaturated compounds. Okay, unsaturated compounds. Consider this: compounds of carbon having a double or triple bond between them are referred to as unsaturated compounds. Okay, here we have the simplest example. This is the example, first example. Here all the bonding is single bond, so they are saturated. So it consists of only one carbon atom. This is a methane and this is a ethene. We will study about it in the next slide. They have a double bond here. This compound is unsaturated. Okay. Hydrocarbons. Here also let's split the word. Okay. Hydrocarbon. Hydro, that is H. C, carbon. So compounds that contain only hydrogen and carbon atoms are referred to as hydrocarbons. So Carbon compounds that contain only carbon and hydrogen is referred to as hydrocarbon. Understand? Then we have already studied about the saturated and unsaturated compounds. In this particular hydrocarbons, if they contain only single bonds, then they are referred to as alkenes. Okay, alkenes. So saturated hydrocarbons are referred to as alkenes. Then unsaturated hydrocarbon which contain one or more double bonds are referred to as alkenes. Okay, and those containing one or more triple bonds is referred to as alkynes. Understand? So let's consider a simple example. In case of saturated hydrocarbons, there will be only single bonds. Consider butane, which consists of 4 carbon atoms and all are linked by single bonds. Okay. In case of unsaturated, can be divided into 2, and one with those contains double bond is referred to as alkenes, and those that contain triple bonds can be called as alkenes. Okay, understand? Then let's move to another slide. Allotropes. What does it mean? Okay, let's go through this. Allotropes. They are different structural form of same element. They are different structural form of same element, but they differ in structure. So that is the structure is what that makes it different from each other. So allotropes are different structural form of same element existing same physical state but exhibiting different physical and chemical properties are referred to as allotropes. Let's consider 3 examples of allotropes. So all these are allotropes of carbon. Okay, all these are allotropes of carbon. Here graphite. In case of graphite, we have in the first slide we saw that one exception is there for the conducting nature of this carbon compounds, that was graphite, because they are conducting nature. Why is it so? In case of graphite, each of the carbon atom is linked to 3 other carbon atoms. Okay, there one more electron is there, that is delocalized. That is, instead of a carbon atom, they are linked by double bond. Okay, that double bond, electron in that double bond can be delocalized, and it also have a 2-dimensional structure. Okay, 2-dimensional structure like a sheet. Okay, they can slip against each other and there are delocalized electron. That is what that makes it different from other compounds. So it can undergo conduction. Okay, they are used as lubricant. But in case of diamond, here each of the carbon atom is linked to 4 other carbon atoms. Okay, they are linked to 4 other carbon atoms and it have a 3-dimensional structure. Okay, here each of the carbon atom is linked to 4 others and they have a 3-dimensional structures that gives them a solid nature. They have a solid nature and it's the hardest ever material that is non-nature. They can be used for cutting. And we are all familiar with this word diamond. Okay, the precious metal. Okay. After that, fullerene. It consists of 60 carbon atoms. Buckminster fullerene. From this the word is taken. Buckminster fullerene consists of hexagonal and pentagonal rings and consists of 60 carbon atoms and have a spherical shape. Okay, this is semiconductor. Here it is a non-conductor. This is an insulator. In case of diamond, it is an insulator. In case of graphite, it is conducting. Okay, so we under the topic allotropes, what does it actually say? They have different structures. Because of this difference in structures, they are exhibiting very different properties. And we have come through the examples graphite, diamond and fullerene. Okay. Okay, now let's study about the structure of carbon compounds. Okay, structure. We have already know the property of carbon, that is catenation. They can undergo self-linking with the help of that property. Okay, now with the help of that property, they can form different structures. They can be chains like this, they can be rings like this, they can undergo branching like this. So let's consider these examples. Two different examples. So both of them have 4 molecules of, so 4 atoms of carbon and same number of hydrogen, but they are represented in different forms. Okay, compounds with the identical molecular formula and different structures are referred to as structural isomers. Okay, structural isomers, they have same molecular formula but different structural formula. In both this they have 4 carbon atoms and it have how many hydrogen atom? It have 10 hydrogen atom. Okay, C4H10. So it's an alkene. 4 into 2, 8 plus 2, okay, 10. So alkene, this is an alkene, this is a saturated carbon compound. Okay, it have 4 carbons, so it's a butane. So let's move through this second one. So far we have studied the compounds which contains only carbon and hydrogen. Now let's study about the compounds of carbon with some other atoms or functional groups added. So carbon can also form bonds with the other elements like halogens, oxygen, sulfur, nitrogen and so on. So these atoms that are replacing this hydrogen atom in this hydrocarbon are referred to as heteroatom. If it is a group, then it's called a functional group. Consider these words: functional group, heteroatom. So the element that is replacing hydrogen is referred to as heteroatom, and the group that is replacing the hydrogen. So why I am saying this replacing hydrogen? So in case of carbon compound, they contains only hydrogen and carbon and this valencies. In this valencies, these compounds are formed by, here if it was a hydrogen, we replace this hydrogen and we'll get another, say a chloropromo or chloro group. Hydrogen is removed and chlorine comes. So we remove one hydrogen and a chlorine comes. Okay, that atom or the element or group that is coming in is referred to as heteroatom, and the group, if it is a group, then it is called functional group. Let's study some basic functional groups here. Alcohol, they have the formula of OH. Okay, aldehyde, CHO, ketone, C double bond O. Okay, the other valencies, like in this case the free valency is attached to the carbon atom. Once this hydrogen is removed, this replace this hydrogen and OH will come like this. In case of aldehyde also, this valency will be here, comes here. Okay, and case of ketone, it comes like this, C double bond O. And carboxylic acid, C double bond O and single bond OH. You have to by heart this table. Okay, this is very important. You have to by heart this table in order for naming and to understand different kind of compounds and nature. Okay, let's move to the next slide. Homologous series. Homo, consider that words, homo, they differ by same group. Okay, these are the series of compounds that differ by same group. Consider alkenes. Okay, alkenes, CH4, C2H6 and so on, and like that. They will differ by a CH2 groups, CH4, C2H6. They are differed by a unit CH2. So consider these two compounds. They also differ by CH2OH group. Okay, if we continue like that with increasing the number of carbon atom and hydrogen atom and with the attachment of these functional group, they'll all have the same property. With this group in it, all of them are together called alcohols. Okay, and with this difference of CH2 alone, they are called alkanes. Okay, let's consider this general formula for alkanes, alkenes and alkynes. We have already studied that. These are unsaturated and this is saturated. Okay, we have already given this general formula CnH2n plus 2, where if there is only one atom, one carbon atom, then N is equal to 1. With the help of this, you can easily name the compounds. Simple hydrocarbon compounds can be named with the help of this. Okay, if you are asked for writing a carbon compound, an alkane that contains 4 carbon atoms, then how will we write? N is equal to 4. You just have to substitute this value in it. So C4. Okay, then double of 4, 4 into 2, 4 into 2 plus 2, double plus 2, that is C4. 2 into 4 plus 2, C4H6. Similarly, we can name all these alkenes and alkanes. that is CnH2n plus 2. For alkenes, CnH2n, and for alkynes it is CnH2n minus 2. Okay, and here with increase in the molecular mass there will be gradation in their property. Say for example, solubility increases, melting point increases because the molecular mass is increasing and the functional group is coming in. So altogether some different new properties are getting added to these compounds, right? Okay, the chemical properties solely depends upon the functional group, which gives them similar chemical properties. Okay, with the addition of this functional group, they are getting a very new chemical property. Okay, they become alcohol, they become aldehyde or an acid. Okay, now nomenclature of carbon compounds. Here in this part, we will study how to name different carbon compounds and the rules that we follow while naming these compounds. So first of all, let's just go through this content. Okay, first of all, identify the number of carbon atom. That is, they are saying us to understand the total number of carbon atoms that are present in the compound. That is, we are trying to understand the root number of carbon atoms. For that, we have to know about these things. The root word. That is, if there is only one carbon atom, the root word will be meth. For two carbon atoms, it will be eth. Meth, eth, prop, but, pent, hex, oct. Okay, likewise up to dec. Or even more, you can study at least up to 10 for this standard. Okay, after that in higher classes you may have to study more about this. And this is the basic format while naming a carbon compound. That is root word, it will have a suffix, secondary suffix, primary suffix and prefixes. Okay, let's go back to the previous slide. Nomenclature. First of all, we have to identify the number of carbon atoms. In case of functional group is present, we have to identify that and their name has to be indicated in the name. For example, chloropropane. From this, let's consider this as an example. Propane. So there will be 3 carbon atoms. 3 carbon atoms. Okay. It consists of one chloro group. Okay. Chloro group. And the rest have to be filled with hydrogen. Okay. This is a chloropropane molecule. Make sure all these valencies are filled with hydrogen. This is a chloropropane. Okay. Similarly, propanol. What is propanol? Here an aldehyde group is coming in. Okay. What is the functional group of aldehyde? See double bond O, single bond H, CHO, simply CHO. Okay. That is propanol. We will study more examples in the coming pages. Okay. Then next rule is, if the name of functional group is to be given as suffix, that is, if it is to be given like this, like in the end, then, and if the functional group begins with A, E, I, O, U, the name of the carbon chain is modified by deleting final E. For example, consider propane. We are considering propanone. Okay. Here propane and the keto group is coming in and the end group is E. This E is removed and the ONE is added. From where I am getting all this? This is alcohol, aldehyde, ketone, carboxylic acid, and here are the suffix and prefix that I am using all these times. Okay. In case of haloalkanes, they have to be used as a prefix. They have to be used as a prefix. Chloro, bromo, likewise. In case of alcohol, it is used as a suffix and the suffix is ol, O-L, ol. Propanol, this OH group is coming in. Okay. In case of an aldehyde, an al group is coming in. So, al group, not the suffix is al. Propanol consists of 3 carbon atoms and this is the aldehyde group. So, propanol. Okay. In case of ketone, the suffix is O-N-E. Okay. Propane plus on, the E is eliminated. Okay. Here also E is removed propanol, all. They are starting with A. Okay, in case of carboxylic acid, OIC acid, this is OIC group, is used as suffix. In case of alkenes, ENE. In case of alkynes, YNE. Okay, you have to by heart this table also, Then, let's come back to this page. Then, if the carbon atom is unsaturated, then it has to be ane. The final ane has to be replaced by either ine or ene. Ene or ine. If it has double bond, ene. If it has triple bond, ine. Okay. Then we have already said about the root word. This type of how we are writing the name, the root word, the suffix, and the secondary suffix, prefix, and all. Let's study step by step. Okay. First of all, we have to identify the number of carbon atom in the chain. While counting the number, we have to keep in mind we have to consider the longest carbon chain. Okay. Now, if I'm here in this case, we can count like this. Stop. Okay, we have already studied about combustion. What will be the general byproducts produced during that process? Okay, let's consider the types of combustion. So I have already said about the incomplete combustion, what will happen, and I have given a simple clue there. And here let's consider complete and incomplete combustion. What's the difference between them? In case of complete combustion, it happens only in the presence of plenty of oxygen. There will be plenty of oxygen in this kind of combustion. And it will give rise to non-luminous flame. Non-luminous flame means a blue color. You might have seen this in your household, like while lighting a gas, you can see this color. If all the air holes are clean and there is no stoppage in the flow of gas and there is no dirt in that, then we can see this kind of flame in our gas stove. Okay. And mainly the byproducts will be carbon dioxide and water. And saturated hydrocarbons generally give rise to clean flame, but in case of absence of oxygen or if there is no sufficient oxygen, then it will also undergo incomplete combustion. In case of incomplete combustion, they occur in the presence of limited oxygen. It will produce soot, that is carbon particles. It will be a dark color thing that will be formed on the surface when we can see that. Say here, this black colored thing that is formed will be formed during incomplete combustion, and it will give rise to luminous flame, that is yellow colored, orange colored, that kind of thing. Okay, that produces carbon monoxide, the carbon and smoke. So it will produce this poisonous gas. Pollutants are giving rise here in this case of incomplete combustion. Okay, now consider oxidation. Oxidation. What is oxidation? Addition of oxygen. Oxidizing agents. Then what will be oxidizing agent? These are simply substances which are capable of oxygen, adding oxygen to the others. So here we are using this alkaline KMnO4, that is alkaline potassium permanganate or acidified potassium dichromate. Okay, either of this can be used in the presence of heat. This alcohol gets converted into an acid. What's the difference here? You can see two hydrogen atoms will be removed and the oxygen atom is coming in. Okay, and oxygen is getting added. Understand? So in case of oxidation, this alcohol in the presence of an oxidizing agent, they will give rise to an acid. Next reaction, addition reaction. This will happen only in case of unsaturated hydrocarbon, which we have already said in the intro part. That is unsaturated hydrocarbons in the presence of a catalyst. Catalyst, what is catalyst? They themselves doesn't undergo any problem, but it will increase the rate at which these products are formed. So these catalysts are substance that increase the rate of this chemical reaction without undergoing any kind of chemical change to itself. So here we are consider an alkene in the presence of a nickel catalyst. They undergo hydrogenation. That is, a molecule of hydrogen is getting added here. This double bond is broken and two hydrogen atom is distributed to here. Understand? In case of addition reaction, They occurs in case of unsaturated compounds, and this happens in the presence of a catalyst. The substance, what is a catalyst? A substance that increases the rate of reaction. Okay, here this alkenes or unsaturated compounds in the presence of a nickel catalyst is undergoing hydrogenation. They are adding hydrogen to the compound and removing this double bond. Okay. Substitution reaction. Usually these saturated compounds are fairly unreactive. Why? Because all their valencies are filled, they are almost stable. But in case of sunlight, in the presence of sunlight, this hydrogen atom gets simply removed and the chlorine comes in. For example, consider this. Saturated hydrocarbons are fairly unreactive because they are inert in nature in the presence of most reagents. But in case of sunlight, chlorine is added to hydrocarbons at a very fast reaction. So that is chlorine, the chloro group can easily replace hydrogen atom one by one. That's called a substitution reaction. So saturated hydrocarbons in the presence of chlorine atom and the presence of sunlight, in the presence of sunlight, and this chlorine atom get easily added up, and this is formed. What is formed? The substitution reaction is undergoing here and this compound is formed. CH3Cl. You may know about chloroform that is used in films for kidnapping someone, and they are actually stored in lab in black color bottles. Why? Because it simply reacts with the sunlight and a new product will be formed, and they can undergo hydrogenation. They, like here, consider this is a chloroform and they can undergo more substitution. All this hydrogen can be replaced by this chlorine atom. That is why they are stored in that kind of bottles. Okay. Let's consider some important carbon compounds. Here we are considering specifically ethanol and ethanoic acid. Ethanol, what is the formula? It will consist of two carbon atoms and OH group, and the remaining will be filled by hydrogen atom. So ethanol. Okay, we are considering ethanol. Let's consider simple properties. They are liquid at room temperature. They are simply alcohol. They are liquid at room temperature. It is soluble in water in all its proportion. Okay. Sir. Okay, now let's consider some important carbon compounds, hydrocarbon compounds. So here we are considering specifically ethanol and ethanoic acid. First, ethanol, meth. How many carbon atoms will be there? 2. And it consists of all groups, so it have a OH group. Okay, the remaining valencies are filled by hydrogen. Okay, this is structure, simple structure. So we are discussing about ethanol. Let's consider its properties. This is simply alcohol. So they are liquid at room temperature and they will be soluble in water at all its proportions. They are commonly called alcohol, and small quantities of dilute ethanol causes drunkenness. You might know this. And let's move to the second one. But even small quantities of pure ethanol, also called absolute ethanol, if they are consumed, it will be lethal and may lead to death. Alcohol as an additive in petrol, and it is a cleaner fuel. Nowadays we can see that 25% of ethanol it will be upgraded to 50%. This is actually a current affairs, that is we are currently using petrol with this addition of alcohol to make it more cleaner. Okay, let's consider the reactions of ethanol. First of all, what will happen when it react with sodium? This ethanol, in the presence of sodium, it just remove this hydrogen atom and the sodium Na plus will simply come here. So the compound will be sodium ethanoxide and a hydrogen molecule is removed. So with the sodium it will lead to the evolution of hydrogen and the product form will be sodium ethoxide. You just simply have to go through these reactions and understand what will happen when a metal react with alcohol. Okay. In case of unsaturated hydrocarbon, what will happen? Reaction to keep unsaturated hydrocarbon. What is happening here is, in the presence of a concentrated acid, this alcohol is undergoing dehydration. That is, a molecule of water will be removed. A molecule of water will be removed. Okay. And what will happen there? Here from this OH and from here one H is removed. One H is removed. Okay. From this a hydrogen and from this OH. In total an H2O molecule is removed and a double bond will come here to form a alkene. What alkene is this? Methane, C2H4. So they are giving rise to an unsaturated compound while undergoing dehydrogenation. Okay, dehydration. Okay. Now let's move to the second compound, ethanoic acid. Ethanoic acid. Okay. What is ethanoic acid? How many carbon will be there? Two carbon atom. But here the compound is ethanoic acid. The functional group is COH. So the remaining valences are filled by hydrogen. Ethanoic acid. Okay. Ethanoic acid is commonly called acetic acid. Okay. 5 to 8% of acetic acid in water is referred to as vinegar. You may know this. We will use this as a preservative in our household while pickling. Okay. While making pickles. Okay. The melting point of pure ethanoic acid is 290. So it often freezes it during winter. 290, 273 is normal. 273, 290 minus 273. What is it? 17 degrees Celsius. Okay. At that temperature, you will undergo freezing and that give rise to glacial acetic acid. So what will be the difference is that the hydrous part of this acid will be removed during that time and they'll get undergo freezing. Okay, carboxylic acids are weak acids. Weak acids because they undergo incomplete ionization. They does not undergo complete ionization, they will undergo incomplete ionization. That is why they are called weak acid. Okay. Reactions of ethanoic acid. First of all, let's consider this esterification. So we have come to this name reaction called esterification. From this itself, we can understand the product esters. In this reaction, the product formed are called esters. They are fruity smelling substances. They are used in perfumes. Okay, and in flavoring agents. Okay, what's the reaction? Let's consider. In case of acid, in the presence of an alcohol and in the acidic condition, it gives rise to an ester. Okay, CH3COOH, CH3CH2OH. What happens here? CH3, C double bond O, single bond OH, and here CH3, CH2, and we have this OH group here. What happens here? This molecule of water is removed and the remaining gets linked. So we get CH3C double bond O, this single bond O, CH2CH3. That's the compound that is formed. A water molecule is removed. Okay, from this a water molecule is removed in the presence of an acid and it gives rise to the compound called ester. So in general, an acid reacts with the alcohol in acidic condition and a water molecule is removed and it will give rise to an ester, which is a fruity smelling substance that are used as flavoring agents and also in perfumes. Okay. Saponification reaction, another name reaction. Okay. What happens here is this so formed ester in the presence of an alkali like sodium hydroxide, it gives rise to an alcohol and sodium salt of the other one. The first thing. What was the alcohol used there? C2H5OH. We'll get back that alcohol and the sodium salt of this acid will be formed. Okay. In case of saponification, what is happening is this esterification get reversed and the product get reversed. That is, the ester in the presence of an alkali give rise to the alcohol that we used in that reaction and the sodium salt of that acid. And the sodium salt of an acid, it have an importance. Okay, now consider this. Ester on treating with sodium hydroxide, which is an alkali, get converted back to alcohol and sodium salt of carboxylic acid, and this reaction is referred to as saponification. This is used in the preparation of soap. So what is this compound? Soap. So soaps are sodium salts of long chain carboxylic acid. Okay, in this way we are producing soaps. Soaps are sodium or potassium salts of long chain carboxylic acid. So we are studying two things from the same thing. Like if we are with help of an alcohol and acid, we are giving rise to esters in acidic condition, and that ester in the presence of alkaline condition is giving back this alcohol and sodium salt of that acid, and the sodium salt of that acid is referred to as, or long chain carboxylic acid is referred to as soap. Now, reaction with the base. With the base, this acid simply gives rise to sodium salt of that acid. Okay, ethanoic acid reacts in the presence of basic conditions to give rise to a salt. Here, sodium ethanoate is called as, or sodium acetate, and water. Reaction with the bicarbonate and hydrogen carbonate. Hydrogen carbonates are simply called bicarbonates. Okay, bicarbonates. Reaction with the hydrocarbons. This reaction with the carbonates and hydrogen carbonates. Ethanoic acid reacts with the carbonates and hydrogen carbonates to give rise to a salt, carbon dioxide and water. So acid in the presence of a carbonate, this is a carbonate, it gives rise to sodium salt of that acid, water and carbon dioxide. And similarly, the acid in the presence of bicarbonate, again it will give rise to sodium salt of that acid, water and carbon dioxide. So in this, it is simply the sodium salt of that particular acid is given as product along with the byproduct of water and carbon dioxide in case of if it is reacting with the carbonates. Okay, I'll say it again. On reaction with the base, they will simply give rise to a salt of that particular atom present in that base and water. In presence of carbonates and hydrogen carbonates, along with that sodium salt, it will give rise to water and carbon dioxide. Okay. Soaps and detergents. We have already come across that. Soaps are sodium or potassium salts of long chain carboxylic acid. And here we are also saying about detergents. They are sodium salts of sulfonic acid or ammonium salts with chloride or bromide ions. Okay. And micelle formation. Before that, let's see this. This is a micelle. This is a micelle structure. We know this is the structure. This is what is soap, sodium salts of long chain carboxylic acid. Okay, this sodium part, this is hydrophilic, and this long chain part, this is hydrophobic. And look at this, hydrophilic and hydrophobic part. Okay, micelle formation. This soap works with help of this micelle formation. In this, what happens is here, this hydrocarbon part, which is hydrophobic, that is, they don't like water, and the hydrophilic part, they love water. Okay, philic, loving. Okay, here the hydrophobic part get attached to the dirt, which is usually a hydrocarbon, and the hydrophilic part is facing towards the water. They form a structure like this, and because of this ion-ion interaction, this is also sodium atom, this is also sodium atom. Because of this ion-ion interaction, this structure remain intact and doesn't form a precipitate, and in that way we can simply wash the clothes and make it clean. Okay, now consider this micelle formation. The ionic end of the soap interact with the water, while the carbon chain interact with the oil, that is the dirt, and thus form the structures called micelles. This forms an emulsion in water. So separate, they are not completely mixed together. Okay, and the micelles stay in the solution as a colloid and come together and will not come together to form a precipitate. Why? Because there is ion-ion repulsion. So they doesn't form a precipitate. The soap micelles are large enough to scatter the light, so this can appear cloudy. Okay, these are just properties. They can appear cloudy, and because of this size, and they are from a colloid. These are not the actual content. We have to consider the micelle formation. That is, hydrocarbon part is hydrophobic, and the sodium part is hydrophilic. They form this kind of structure, and they remain intact because of anion repulsion. With the help of this, we can easily clean the clothes. Okay. Here it is represented with help of these figures. So this is micelle, and these are the soap molecules. This is the dirt. The hydrocarbon part get attached to this dirt, and the other hydrophilic part protrude out like this. And on washing, it remains intact. And this is soap micelle, dirt within the soap micelle. In that way, it is removed, and we get a clean cloth. Okay. Then, hard water. You might have seen in some water the soap doesn't give much lather, much bubbles. It may even give rise to some solid scums. It is because of the presence of calcium and magnesium salt. Okay, if the water contains calcium and magnesium salt, then it will does not give rise to a good lather, and that kind of water that contains calcium and magnesium salts are referred to as hard water. But here we have a solution. Detergents. Solution is, in case of hard water, what is the solution? We can use detergents because these are also, we have already studied that detergents are generally sodium salts, sulfonic and ammonium salt. These things doesn't form precipitate with this hard water. So with help of detergents, we can easily clean the clothes if it is a hard water. Okay, that's all about the class. Thank you.